from quantum mechanics, concepts and application from Noureddin Zetili. So we are basically looking at question 1.23. 1.23 says, photons of energy 0.7 mega electron volts are scattered from electrons initially at rest. Now, if the energy of the scattered photons is 0.5 mega electron volt, find the wave shift. So the photon has got the energy. So the energy of the photon is actually 0.7 mega electron volt. And the scattered photon energy, so this is the energy of the photon, And we were given another energy, which is 0.5 mega electron volt of the scattered. So this is scattered photon. And now we know that we can convert. So before we go further, let's first convert. So we can convert the value of mega electron volt to electron volt. So mega electron volt to electron volt. So what do? We take 0.7 mega electron volt. We multiply that with the 10 to the power 6 electron volt divided by 1 mega electron volt. That will give us a 0.7 by 10 to the power 6 electron volt. Let's keep this value in our calculation. Even the 0.5 mega electron volt, we multiply by 10 to the power 6 electron volt divided by 1 mega electron volt to give you a 0.5 by 10 to the power 6 electron volt. Now, we know that the wave shift, so we come back and say wave shift. So the wave shift is delta lambda. And our delta lambda is defined as our lambda prime scattered minus our lambda, the wavelength, the shifting wavelength minus the wavelength. So, but we know that the energy of a photon, is given as E is equals to H F, right? Where H is the Planck's constant. Let's define every term there, and we'll say this is energy. And this one is the Planck's constant. The Planck's constant, which is actually a 6.63 by 10 to the power negative 34. Is joules dot second. And this is frequency. So this is frequency. Right. So basically we have got energy is equals to HF. But now we want to know the frequency, the speed of a wave is equals to F lambda. And remember, we want to replace our F, right? So our F will become C over lambda. So energy E is equals to H C over lambda. And our energy is equals to HC over lambda. And then our lambda is equals to HC over E. So from delta lambda is equals to delta phi minus delta, our delta lambda will become bracket HC over lambda prime minus HC over lambda. But you must know that HC is a constant. A constant. That will give you what we call electron volt nanometer. And the value of HC was approximated to be 1240 electron volt dot nanometer. So we can take out our constants there. Is HC is a constant. Then we will definitely have, why did I put lambda? Sorry, that was a mistake here. It's supposed to be E, and this one is E2. So it's actually 1 over E prime minus 1 over E, like this. But remember that our energy, photon, so this one is the photon energy, and this one is the photon energy scatter. So photon energy scattered. So basically, what we are going to have is our delta lambda is going to be a bracket 1240 electron volt dot nm bracket, and then we open 1 over, now the first one is going to be a 0.5 by 10 to the power 6, the minus 1 over 0.7 by 10 to the power 6, and then we multiply that. So if you do the calculation using a calculator, you must definitely get a 7.09 times 10 to the power minus 4 nanometers. So this is our shifting wave from the question. The question asks us to find the wave shift. So this is the wave shift. We can put it in another color. This is our wave shift here from the calculation on A. Let's get to B now and see how far we go. So B is asking the angle at which the photon scatters. So the angle at which the photon scatters is coming from the formula that says, the question says delta lambda is equals to HC over C bracket 1 minus cos theta. From the previous calculations, we discovered that HC is a constant. Let me just write it in another color to make our understanding better. So we discovered that HC is a constant. I won't repeat, but we discovered that our HC is approximately, so that is approximately 1240 electron volts dot nanometers. And now we have got MEC. MEC, normally we can make it a constant by saying, can be written as MEC or squared over C here to make our life easy because MEC squared is known to be approximately 0.511 mega electron volt, and MEC there, which is mega, this is the minimum energy required to create an electron or released when it is annihilated. So the minimum energy required to create an electron, or energy released when it is annihilated. That is the HC. So that is MC square. So ME of C square, remember E is the rest mass of an electron, 0.511 mega electron volt. So it can be changed to electron volt, which is 0.511 electron times 10 to the power 6. Remember from the previous calculation, times 10 to the power 6 electron volt. So we have got this number here. So let's go back to our equation, which says delta lambda is equals to HC over M, which is not HC, it's H, sorry, here it's H. HEC bracket 1 minus cos theta. Right, so definitely remember that we changed our MEC to become MEC squared divided by the C. So we put it in here. So our delta lambda becomes H over MEC squared over C of 1 minus cos theta. That is to say, delta lambda is equals to HC over MEC square bracket 1 minus cos theta. That is to say, now we can take this to the other side. Delta lambda bracket MEC square all over HC is equals to 1 minus cos theta. And now we want the theta, so it's going to be cos theta is equals to 1 minus delta lambda of MEC square bracket all over HC. Then we want the theta. So theta is equals to arc cos of what? 1 minus delta lambda bracket MEC square all over HC, like this. Then it's going to be arc cos of what? 1 minus the 7.09, which we calculated in A, times 10 to the power negative 4, multiplied by 0.511 by 10 to the power 6, or over 1,240. If you do your calculation, you will get your angle theta is equals to 44.94 degrees. So this is the scattered angle, because the question is asking us to calculate the angle at which the photons scatter. So this is the angle. So this is the angle which the photon scattered. So this is the answer for B. So we go to question C now. So question C is saying, calculate the angle at which the electrons recoiled. The angle at which the electron recoiled is calculated by tan. Phi is equals to sine theta divided by 1 plus delta lambda over lambda minus cos theta. Now, all this is the equation for calculating that. I don't know where this thing came from, so we say equals here. Okay, so this is the equation where we will calculate our angle from there. So now, the first thing we do is we know our theta, which is 44.94 degrees. We know our delta lambda, which is 7.09 by 10 to the power minus 4 in nanometers. Then our lambda is calculated from hc over E, the energy of a photon, which is going to be a 1240 electron volt nanometers. I like meter, nanometers divided by, remember the 0.7 mega electron volts, we just say times 10 to the power 6 electron volt. Then we'll get our answer is 1.77. This is nanometers. Right. So times 10 to the power 3, times 10 to the power times 10 to the power negative 3 nanometers. So we have got everything. So the angle phi is actually arctan of the sine theta over 1 plus delta phi lambda over lambda minus cos theta, like this. So we go further and say now our arctan of sine 44.94 degrees divided by 1 plus 7.09 times 10 to the power minus 4 divided by a 1.77 times 10 to the power minus 3 minus the cos of 44.94, right? Like this. It will definitely, if you do your calculation with the calculator, you definitely get a 45.56 degrees. This is from the question, the angle at which, so this is the angle phi at which the electrons recoils. The angle at which the electrons recoils. So the last question is D, the kinetic energy of recoiling electrons. So the kinetic energy of recoiling electrons is E is equals to H of phi minus frequency of that, like this. So which is going to be the energy from the scatter minus the energy of that. That is going to be a 0.7 minus a 0.5. That is very easy, which is a 0.2 mega electron volt. Yes. So remember, this is quantum mechanics, and it's found in the textbook, the exercise. I'll do more questions. If you have got a question, let me know in the comment section, and please subscribe and love my channel. Thank you very much.